Of course, it'd be more bad if I could see without my real glasses, but we are going to talk about predictions. So you're used to how to see the computer output. We've got data on age versus sleep. Sleep goes from either 4 hours up to 9 hours, and age goes from 20 up to 80. So 20-year-olds should be getting those 9 hours of sleep. Yeah, I'll bet you are. And 80-year-olds, they don't really need as much sleep. If you have grandparents like mine, getting 4 hours might be a lot for them. So there's this downward trend. We can see the downward trend here. Our slope is negative, and our p-value is small, which means there absolutely is a relationship. Now, I made these numbers up, but what we're saying is as you get older, the amount of sleep you get drops. And I want to try to predict how much sleep you should be getting if you are 36, which I happen to be, or if you were 72, or a 5-year-old. So how do we do a prediction equation? Well, in math class, they used y equals certain letters that I told you to never use again and to forget. But in statistics, we are going to use y equals beta naught plus beta 1x. And we're going to fill those in with our estimates of what we think those values are, which is technically a beta naught hat and a beta 1 hat. But for this case, we're going to have y equals 10.74. That's our y-intercept off here. This is the only place we really need that y-intercept, because the rest of the time we're interested in the relationship, which is slope. And here's our slope. It's a minus instead of a plus because it was negative here. 0.0833 times the value of x. What is x? X is the value of age in our case. So what I'm going to do is I'm going to take my 36, multiply it by the slope, add it to that y-intercept, and that'll be my prediction. It'll look like this. I take 10.74 minus the slope times my 36, 7.7412. So I should be getting just less than 8 hours of sleep. Actually, that sounds really nice. I wish that was true. What if I was a lot older? When I'm a grandpa at age 72, I expect I won't be getting as much sleep. Looks like just about 5 hours of sleep. I think that's about how much my grandpa does sleep. Now keep in mind, order of operations, these guys have to multiply first before they get added on. If you've got one of those really smart calculators like a TI, they know about the rule of order of operations, but if you're doing it in pieces, multiply these guys first, then add. Don't take 10.74 minus 0.0833 and take that answer times the x value. That's not going to work. Now let's talk about a 5-year-old, which I just happen to have a 5-year-old. If you thought it was going to be like these guys, you are wrong. If you did this, notice it's in red, then you got the wrong answer. What is it that makes this different? Well, for one thing, I hope you noticed 10 hours of sleep. My 5-year-old, yeah, right, not going to happen. Actually, he was ornery yesterday. That might have been a good idea. The point is, this is not the right way to do it because your range goes from 20 to 80. You do not have any data for 5-year-olds. It's possible that as you start to get older, there's a decline, but it levels off out here, or maybe it even goes back down on the other side. You don't know what happens to the data outside the data range that you collected. So what you need to do is only do predictions within the range of what data you have. If you go outside that range, it's called extrapolation. I know people do it all the time. Go listen to the news. By the year 2075, are you going to tell me you have any data from the year 2075? No, but they're extrapolating. They got data up to this year, and then they say, okay, if that trend continues, and that's the way you do extrapolation, is you make these assumptions about what you believe the data is like outside the range. That's also why they're always wrong. So don't do extrapolation in the homework. If it asks you to do a prediction outside the range that you have, cannot do.